Alright, so 4-1 is matrix operations. The first question then should be, what is a matrix? So a matrix is going to be a rectangular arrangement of rows and columns. And we're just going to do some basic notes today. So a matrix is going to come to you in brackets. So for example, we might have the matrix that is 1, 2, 3, 4, 5, 6. And so you name a matrix, or you identify a matrix by how many rows it has and how many columns it has. So this is going to have 2 rows, and it's going to have 3 columns. And so we're not really going to identify them too much, but you might label it as matrix sub 2, 3 for rows, columns. And you always name them a letter. So maybe this is matrix M, but this could also be matrix B. And so one of the first things we want to do is we want to add matrices together. And so you can only add matrices that are the same size. So if that is matrix B, maybe we have matrix C that is 7, 5, 2, 9, 4, 6. So to add these together, you add the same entry. So the entry 1, 1 would be first column, first row. So if I wanted to do B plus C, I would be adding 1 plus 7. So there would be an 8 in the first position. And then 2 plus 5 would be 7. And then 3 plus 2 is 5. And then the second row, second row, first column, 4 plus 9 is 13. Then we have 9 and 12. And that would be B plus C. So let's say that we have a matrix D that's 2, 3, 4, 5. Could I add C plus D together? So the answer is no, because they don't have all those entries that line up. So to add or subtract, you can do the same thing if I was to subtract 2 matrices, is you just take those same entry places and add and subtract them. So the next thing we want to do is multiply by a scalar. And a scalar is just a number. Okay, so like 2, 3, 4, it's just a number. So if I have matrix A, and let's say it's -1, 3, 6, and -5, and I want to multiply it by a scalar. So maybe I want to take 2 times A. And so you would write it, 2A, and what that means then is 2 times -1, 3, 6, -5. And then you distribute that 2 to the matrix, to everything in the matrix. So we're going to end up with -2, 6, 12, and -10. Okay, so at the moment, your assignment is to do page 203, 18, and 20. So 4-2 is multiplying matrices. And when you multiply, they don't have to be the same size like they do for adding and subtracting, but your number of columns in the first one has to match your number of rows in the second one. For instance, you can multiply, I'm just going to put in some 1s here. I can multiply, that's a 1 by 3, because it's 1 row, 3 columns. You can multiply that by a 3 by 1. And the reason is because of how we multiply. So we're going to start out by just multiplying 2 2 by 2s. So let's let matrix A be 4, 1, 0, -2, and matrix B is going to be -4, -3, 1, and 2. And the first thing we want to find is AB. So the process here is that we are going to take, for the first column, first row, we actually take the first row and the first column and you multiply the entries and then you add them together. So in this case, I'm going to write out what we're going to multiply here. We're going to multiply 4 times -4, so that would be the first entry in each, plus, then we're going to multiply 1 times 1, which is the second entry in each. So that answer, let's go ahead and get that answer. So you can have -16 plus 1, so that's going to be -15. That's your first entry. And then for first row, second column, we still multiply first row, but now we multiply it by the second column. So we're going to do 4 times -3 plus 1 times 2. So that's the first row times the second column. Alright, so that gives us -10. So now I'm on the second row, and I'm going to do second row, first column, because that's this entry here is the second row, first column. So we're going to do 0 times -4 plus -2 times 1, which is -2. And then for second row, second column, I'm going to multiply the second row times the second column, which is 0 times -3 plus -2 times 2, which is -4. Alright, so let's do an example on two that are not the same size. So we're going to let A be -3, 3, 3, -2, and 0, -1. And B is 1, 0, -2, -1. By the way, the order that you multiply matters. So if we go back to the last example and we switched it and we found B times A, you would actually get a different answer. Okay, so the order that you multiply does matter. If you're ever asked to multiply and find AB or BA, they are different. Okay, so let's find AB here. And so my first row, first column entry is going to be the first row times the first column. So -3 times 1 is going to be -3 plus 3 times -2 is -6. And that then is going to give us a -9. Alright, so now to find first column, second row, we're going to take the first column times the second row. -3 times 0 is 0, plus, then we're going to do this 3 times -1, and that is -3, and so that gives us a -3. Alright, so now we're going to move on to the second row. Here's second row, first column. We're going to do 3 times 1, which is 3, plus -2 times -2, which is 4. So that one gives us a 7. And then second row, second column, 3 times 0 is 0, plus -2 times -1 is a +2. So that gives us 2. And now we're going to move on to the third row, first column. So we're going to have 0 plus 2, which is 2. And then we're going to have 0 plus 1, which is 1. So there is adding two matrices of unlike size. So at the moment, you need to do page 211, 20, and 22. So what we want to do now is we want to use a matrix to solve a system of equations. Before we can do that, though, we have to learn how to figure out the determinant of a matrix. And the determinant is just a number associated with the matrix. And depending on what size of matrix it is how you find your determinant. So the first one we're going to find is just the determinant of a 2 by 2. And you would call it DET for determinant. And we're just going to look at the matrix A, B, C, D. And so how you find the determinant is you do kind of what it would be a cross multiplying. Is that we're going to multiply A times D first. So that would be AD. And you're going to subtract from it the product going the other way, which would be BC. Or CB, however you want to say that. So if I want to find the determinant of 7, 2, 2, 3, I'm going to first multiply down this way and get 21 minus, we're going to multiply up this way and get 4, and so 21 minus 4 is 17. And so that would be the determinant of that matrix. And then our next step is going to be to use the determinant, but we first have to find the determinant. Okay, so next we're going to find the determinant of a 3 by 3. And so we would call this determinant. And so at the beginning we're just going to do A, B, C, D, E, F, G, H, and I. So to figure out the determinant, what you need to do is to rewrite the first two columns on the back side of this. So you're going to do A, D, G, B, E, H. So that's the first two columns just rewritten so that you have a 3 by 5. And then we're going to multiply, and just like your 2 by 2, we're going to come down first. And so we're actually going to multiply A, E, I. Make sure that you have them hopefully in line there. So we're going to get whatever A, E, I is, plus, then we're going to come down the next row, B, F, G. And we're going to come down the next row, or next diagonal I should say, C, D, H. And we're going to add all those together, and that's our first number, just like AD was our first number on the last one. And then we're going to subtract from that, and this is where it's going to be important to use parentheses because I want to subtract all of this next thing. So minus, now we're going to come up and across GEC. So there's GEC plus, so we're adding them within these here, HFA plus IDB. And hopefully yours fit on the line. And then so you're going to find those two sums, subtract them, and that's your determinant of a 3 by 3. So a little more work, but doable. You just got to make sure, if at all possible, you get these nice diagonals when you're writing it out. So if you're kind of sloppy, it's hard to see it. So let's try. Let's find the determinant of 4, 2, negative 1, 1, 1, 0, 2, negative 3, 5. So the first step would be to rewrite those two first columns. And you're doing that because you have to get these diagonals in there. Otherwise, you just have one diagonal of 3. So 4, 1, 2, 2, 1, negative 3. And so to multiply, we're coming down first. So 4 times 1 times 5. We could go ahead and just say that is 20. Plus 2 times 0 times 2. Well, anything times 0 is 0. Plus negative 1 times negative 3 is going to be a positive 3. And then it's going to be minus, and now we're coming up the other way, 2 times 1 times negative 1 is negative 2, plus negative 3 times 0 times 4, that's 0, plus 5 times 1 times 2 is 10. So this is going to be 23 minus 8, which is 15, and that's the determinant of that matrix. So we're going to use what's called Cramer's Rule to solve a system of equations. And so it uses the determinant. And the first thing that we need to know is that the determinant cannot equal 0 if there is a solution. So I should say it the other way. If there's a solution, then the determinant does not equal 0. So a solution meaning that these lines cross at one point. So if the determinant is 0, then you know that there is either infinitely many or no solution. But if the determinant actually comes out to be non-zero, you know there is a solution. So you've got to figure out your determinant first. Okay, so we're just going to go right into an example, and we're going to solve the system 2x plus y equals 1, and 3x minus 2y equals negative 23. Which you could just do with substitution or elimination, but we're going to start here and build our way up to solving a system of 3 by 3. So the first thing we have to write is what is called the coefficient matrix. And so the coefficient matrix uses the coefficients. So my coefficient matrix is going to be 2, 1, 3, negative 2. Do you see where I got those numbers from? They're just the coefficients. There's 2, 1, 3, negative 2. All right, and then we're going to have what we could call a constant matrix, which is going to be the other side, which is 1 and negative 23. So I need those two matrices to start with. So your next step is to find the determinant of the coefficient matrix. So I want to find the determinant of 2, 1, 3, negative 2. And so remember, I'm going to multiply coming down first, which is going to give me a negative 4. And then I'm subtracting, multiplying going up, I'm subtracting a 3, which is going to give me negative 7. So because that's non-zero, I know I have an answer. So I can go on now. So to find x, we're actually going to take the coefficient matrix and we are going to replace the x column with the constant matrix. So here's what that would look like. That's going to look like negative 23, 1. No, hold on. I messed up. That's not what that looks like. That looks like 1, 1, negative 23, negative 2. Okay, so I just replaced this 2 and 3 with 1, negative 23. And we're going to divide this by the determinant, which was negative 7. But the first thing I want to do, though, is find the determinant of the top. So the determinant of the top is going to be -2 minus -23. And we're going to divide that by -7. And so we're looking at 21 divided by -7, which is -3. So there's my x value. Okay, so now to find y, we're going to do y equals. So the first thing we're going to do, though, is we're going to keep our x column, but we're going to replace the y column with the constants. So this is 2, we're going to just write it down, 2, 3, 1, -23. We're going to do the determinant of that and still divide by -7. So this is going to be -46 minus 3 divided by -7, which is -49 divided by -7, which is 7. Okay, so still finding the ordered pair where they cross that we're writing as an ordered pair, and so my answer then is -3, 7. Alright, to use Cramer's rule in a 3x3, we're going to solve the system -x plus 2y plus 7z equals 13. 2x minus y minus 2z equals -2, and 3x plus 5y plus 2z equals -14. And so then the first thing you want to do is your two matrices. So I need a coefficient matrix, which is going to be -1, 2, 7. 2, -1, -2, 3, 5, 2. And I need a constant matrix, which is 13, -2, -14. And to save some time and space later, we're going to go ahead and find all 4 determinants now. So our first determinant is just our determinant of our coefficient system. So the determinant of -1, 2, 7, 2, -1, -2, 3, 5, 2. And remember that you repeat the first 2 columns. So we're going to have -1, 2, 2, -1, 3, 5. And then we're going to do our diagonals coming down first. This one is going to be a +2 plus -4 times 3 is -12 plus 70. Okay, and then we're going to subtract coming up the other way. So there would be a -21 plus +10 plus 8. Alright, and so let's figure that out. So that is 63. And then, so that's just your basic determinant. So that's just our determinant. Then we're going to find, we'll call it the determinant of x. And so we're going to replace the x column with your constant column. So the first column is 13, -2, -14. And then you keep the rest of it the same. 2, -1, 5, 7, -2, 2. And we're going to repeat the first 2 rows. And now we're going to find the determinant. So coming down first, we're looking at -26 plus +56 plus -70 minus, coming up the other way, 98 plus -130 plus negative 8. And that is, so that gives us 0. And the next thing we're going to do then is find the determinant for the y. So we'll call it determinant y. And so this time we keep the first column and we replace the second column, which is my y's, with your constants. So the 13, negative 2, negative 14 goes into the second column. And then we want to repeat the first two columns. We're going to find the determinant here. So coming down first, we have a positive 4 plus a negative 78 plus a negative 196. And we are going to subtract from that, coming the other way. I believe that's a negative 42 plus negative 28 plus 52. All right, so if we find that, we have the determinant for our y. All right, so that gives us a negative 252. We're going to have to start a new page, so make sure that you have those three determinants written down, and we're going to go to a new page. All right, so lastly, we need to find the determinant for z. So we're going to keep the first two columns, so the negative 1, 2, 3, and the 2, negative 1, 5, but we're going to replace the z column with our constant column, which is the 13, negative 2, negative 14. And then remember that we're going to repeat the first two columns, so negative 1, 2, 3, 2, negative 1, 5. Finding the determinant of this, we have negative 14 plus negative 12 plus 130 minus, going the other way, negative 39 plus positive 10 plus negative 56. And if we find this, we have the determinant for our z. Okay, so that equals 189. And so now we have all four determinants. So to put this together, to find x, we're going to take the determinant of x over the regular determinant. So the determinant of x was 0. The regular determinant was 63. 0 divided by 63, 0. All right, so to find y, we're going to take the determinant of y divided by the regular determinant. The determinant for y was negative 252 divided by 63. We get a negative 4. And then to find z, we're going to take the determinant of z divided by the regular determinant, which was 189 divided by 63 is 3. And then keeping in mind, we're still finding where these cross, so this is an ordered triple. Our answer is 0, negative 4, 3. So there's the end of finding the answer using Cramer's rule for 3 by 3. So your homework now, let's go to a new slide. You need to finish with page 218. You're doing 16, 18, 22, 26, 38, 40, 46, and 50. There we go. Let me know if you have any questions.